Hi everyone, welcome again. Uh, Today I will show you one of my project which is related to flight booking system using RAG and AI agent. Okay, so let me start my project and I will show you how the working flow of the project. Okay. Okay, so this is the backend where the AI agent is running. Okay, so let me go inside my front end folder. Okay, this is the front end. So we just give command npm run dev. Okay, sorry, we are not inside the right project. cd front end dev. Okay, so this is the front end. Then let's run the pss system. I'll be going to explain this system. We have to run this system in port number 3000. This should be the main.app. Okay, we have a mistake. This should be uv. Okay, now our three system up and running, and let me open the front end on browser. Okay, this is the application. Let me just log out. Okay, so this is the application, and before going inside the application, let's discuss what it is. Okay, so you have a flight portal, flight booking portal. Okay, a second. Yes, this is the booking portal. Then let me bring it here. This is another system. Backend where AI agents, actually AI agent is running, and the rack flow. I kept all this component inside one backend. Then this is another backend, basically the PSS. We need something for flight booking portal, right? A system which can store the passenger details, booking, flight details, boarding pass details, all those things. Passenger service system. Now this front end is connected to the AI agent portal on port 8080. Then this front end also connected to the PSS for some of the functionality on port number 3000. Then the AI agent system also connected to the PSS. Okay, this is how the system look like. Let's go to the front end. I have created 3 users here for the demo purpose. Okay, let me go to login with system administrator. Okay, and I will show you guys what are the features are there. Okay, let me just click on system administrator and click on sign in. Okay, this is the AI chatbot on my screen. Okay, then this is the flight booking portal. Just a minimal workflow. There is no much feature here. I can search the origin, then I can search the destination, then I click on search button. We will see number of flights, and I want to tell you guys these flights details are not real time. These all flight details are kept inside this passenger service system. Okay, we are not connecting to the internet to search any flights here, because this is our demo project, right? I have built it to test the AI agent system. Okay, not a full-fledged flight booking system. So this is just a dummy flight booking portal on which our AI agent will be going to work on it. Okay, then I can select one of the flight here, then I can provide the passenger name, then I can select the seat here, select this one, then I will proceed to the payment. In the payment system, I have configured the rules to validate the payment system in various scenarios. Like if someone want to validate what will happen if the payment system have some issue like network timeout, or a person who have insufficient balance trying to do the payment, or the payment transaction got declined by the bank, right? To replicate those scenarios, I have configured some rules in the PSS system, so that if we will provide these numbers, we can reproduce the same scenario. For example, if I want to make my payment success, I can give the number 4111 and rest of the number I can give anything. If I want to replicate the network timeout, I can give 5100 the starting, then I can give any other number, not an issue. Okay, so let me just try with 4111 and give some random numbers. Expiry date also, there is no validation in the expiry date CVV code because this is not our focus here. So let me just confirm the payment. As you can see, this booking is successful, PNR is generated, seat number, click on done, and in our right side we can see the ticket status which is booked, right? Seat number, correct. This is how we are booking. Then I can go to my booking and profile tab to see the bookings. Here all my bookings will be visible. Then I can click on manage. If I click on manage, I will see other options as well, like if I want to change the seat, if I want to add baggage and lounge information, correct. Then if I want to select any meal, I can choose here vegetarian or other wheelchair assistant. I can select here from this drop down. Then I can reschedule my flight. This will going to simulate the reschedule, like sometime airlines will reschedule the flight, right? So by clicking on this button, we can replicate the same exact scenario for testing purpose. If I'll click on cancel reservation, it will going to cancel the ticket. Okay, so let me just cancel it. You can see booking is cancelled now. Status is also got updated to cancel. Status after cancel. If I'll go to the Chatbot window, here I can see the boarding pass ticket preview section. That ticket got cancelled here. Okay. Then admin have some extra tab here to perform some of the configuration. For example, I can manage the passenger here. I can add new passenger. I can edit their details. Then one more thing, I have integrated the RAG pipeline here in this project. So when we will be going to discuss that process in this project, then this particular UI will make sense, where basically I am uploading the file, and this file will be going to store in the S3 bucket, and automatically it will going to post those file to the one of the vector database. Okay, so we will come to this RAG process later. Then in the system settings, I can select the local model. Also I can select the cloud model as well. As I have already configured the local model, that's why it's showing the local model. Okay, so let me change that configuration quickly. So I have changed the environment to prod. Okay, so that it will be going to choose the pro model GPT-4.0 from OpenAI. Okay, and let me rerun the agents. Let me refresh the page. As you can see now, these are all the cloud models: GPT-4.0, GPT-4.0 mini, okay, 4 mini. Then here the API key is there, we can update the API key. Okay, now let's see a flow. What I'll be doing is I'll be going to book a flight from Bangalore to Delhi. Okay, then I'll be going to cancel that flight. Okay, before doing that, I have created a debugger to debug the tool callings. Like I want to know which tools the AI agent is actually calling. So in this window I can see that. Okay, so let me minimize it. We'll see some of the flow, then we'll see what's the output there we're seeing. Okay, before that let me open my LangSmith also, so that you can see how the tracking is happening there. So today there is no trace here. Okay, let's see what is happening. I'll be going to tell hi. So agent gave us some of the option to choose from. Okay, let's see if any tool call happened. No tool call here. This is just a prompt, and we got the response of the prompt. I'm telling search flights. It's asking, would you like to add other passenger to your booking? I will tell no. Okay, please specify your preferred travel time or range. You can adjust the time using the slider below. Okay, so I'll give as it is from 6 a.m. to 6 p.m. It's asking, do I want a round trip? I will tell no round trip. It's obvious. Now it's asking origin destination. I will tell from Bangalore to Delhi, and I will tell the date also on 10th August. On 10th August. So we can see it's getting the response. Okay, here I want to show you guys something. When we told like I want to book from Bangalore to Delhi on 10th August, the LLM called the search flights tool by passing this information: Bangalore, Delhi, the date, and the time range. So from where this information the LLM got? So Bangalore, Delhi, and the date it got from this line. This is what called the entity extraction. Then the time range from 6 a.m. to 6 p.m. it got from this slider, which one you have selected earlier. Okay, correct. Then by using those information, it called search flights tool. Okay, so in search flight tools, it can search for number of flights on particular date by giving origin and destination. So it got this response from the tool. You can say flight number, those things. And from where this response is coming, this data is coming. These data are coming from the PSS, passenger service system. Okay, so I think I can show you guys that tool. Okay, so let me copy the search flight tools. I will go to my code base. So here I have wrote the search flight tool. So search flight tool have origin, destination, date, and time range, and the return will be a list of object. Now this have the description, correct, which will help the LLM to understand. Then here we are calling to the passenger service system, and after getting the response we are sending it, right? This is one of the two. Now it's giving us the result. Let's select one of the flight. Let's select this one, 110, and you can see if any other call is happening. Let me just keep it side here. Okay, so it's asking us to just review the passenger details. Okay, first name, last name. We can edit this field here. Okay, I can give my name here. Then let's one second. Let's confirm and see what call it's called. So LLM call the book flight tool now. Okay, in this book flight tool, it pass the passenger ID, Bangalore, destination name, booking class, and passenger details: first name, last name, email, passenger type. Okay, and this tool call is successful. It got this information after doing the booking. Okay, now the status of the booking is pending payment. Okay, this is not confirmed yet. This is just we are holding the booking related information in our system, so that once the payment is done, we can permanently create the order of that booking. Okay, so let me click on the proceed to secure payment. Here I'll be provide my name, card number. Same here, I can give 4, then I can write any other number I want to make it pass. So payment is done. my booking is confirmed from Bangalore to Delhi, my name, flight, date, seat, and gate. Okay. Now whatever option you have here, meal, like if I want to select any meals, I'll click on the meal option, then I can choose gluten free meal, one option. Okay, then I will ask I want to choose different, to choose a different seat because I want to change my seat, right? Okay, click here. You will be seeing the flight seat map. So let me select 10F. Okay. So my seat has been successfully changed to 10F. Let me verify. I will ask, show me my booking details. So before the seat was 10A, now after updating the seat, it's become 10F. Correct. And my booking is confirmed now. Okay. So what I can do is I can do the check-in now. Okay. So before doing that, let's see how many tool calls it already performed. So you can see these are the tool calls LLM performed here, and here we can see the input argument and the response. So it will help me to debug if anything wrong happened. Now let's go to the LangSmith. Okay, let me click on threads. So we will I will explain more on the threads and the trace, okay, later, but for now we will see or we will consider this thread is a one conversation which is happening. Okay, if you start a new conversation, that will be another thread, something like that. So inside one thread there will be a more than one turns, like one conversation will be one turns. So we have performed around 14 conversation here. So this is the first conversation. We'll see. We have given input hi to the agent, okay, and during that process, the agent, like our AI agent system, have provided this system prompt to the LLM, okay. Then the output of GPT-4o is this one, basically the LLM, and we can compare this one with our front end. We have sent hi, and you can see these are the options you are seeing, correct, same as it is. Then the second turn, in the second, what was the input? Let's click on the ChatGPT OpenAI and we'll see what is the input here. I have provided input search flights. The next, search flights. What's the response I got? Would you like to add other passenger to your booking? Correct. Then I have replied with no. So that will be part of the next turn. Correct. So this is no. Correct. Then AI come up with the response like please specify your travel time or range. Correct. This is that particular one. So like this, we have a number of turns present here as part of one conversation, one thread. Okay. If we will maintain the conversation like this, it will be easy to test. Then let's see one example of tool calling here. Okay, let's see this one. Okay, so this is the user input. I want to book flight on date and in class Y. Okay, then before proceeding the booking, please review details. We have reviewed. Then what happened? The AI called the book flight tool. This is the book flight tool. In this book flight tool, what are the parameters we have provided? Booking class, date, destination, origin, passenger ID, passenger detail. Then output what we got? This is the output: airline, Indigo, booking class Y, cabin class economy, date, PNR number, seat number, status is pending payment. Okay, then is round trip, false, passengers, price. We got the result from the tool call. So as you can see, uh, by integrating LangSmith with our AI agent system, we can keep track of all those details: input, output, what are the tool call happened, what is the system prompt we are providing to that particular LLM or model. Okay, not only that, what else, like if we can hover on this particular turn, we can see how much token it used. Input token is 4.9k. What is the cost of the input token? What is the number of output token we have generated? And what is the cost of output token? And what is the total token and total price? Correct? And what is if we can see the P50 value, basically the performance, right? 3.80 second of this total conversation. So in this way, we can keep track of token as well. We can keep track of agent response time. So we can see this one 1.22 second, right? The response time of agent, which all this information basically will not available in front end in the real time, right? So if we have something integrated for monitoring, we can find out those information for the testing. Now I have customized the front end to add TTFT, time to fast token, the latency, input token, output token, and the cost for our testing purpose. Correct. Now what I will do, I will going to log out and again I will be going to log in. Okay, so when I will start a new conversation, it will going to create a new thread here. Okay, so I will tell so my bookings, because I have already one booking, right? So as you can see, we are successfully able to retrieve the booking details. Then I will go through the check-in process now. Okay, before proceeding with the check-in for the booking, please review the hazardous material restriction. Let's accept this one. Then since you have already have a seat assigned, are you ready to finalize check-in and issue your digital boarding pass? I'll tell yes. So it will generate a boarding pass for me. As you can see, boarding pass generated. So now I can travel in flight, right? Now let's come here and refresh the page. We will be seeing a new thread here. Okay, sometime the LangSmith will take some time to reflect the new conversation. Okay, yes, you can see there is a new thread now which have only 4 turns, because we have did I think 4 conversation, 1 2 3 and 4. Like one input and one output is 1 turn. This is 1 turn. Then check-in booking PNR, this one to this output is 1 turn. I confirm the safety to this output is 1 turn, and from yes to the boarding pass generation is 1 turn. So total 4 turns. So we can see there are 4 tones present here. Okay. Correct. So now if I'll ask you to cancel the ticket, we'll see what is out. Basically it will tell already boarding was generated, it can't cancel it. So this is part of the business rule validations. Okay, one of the example of this one. Then what else? Like let's see one example of RAG. Okay, now I will ask what is the baggage policy of Indigo. Okay, so what it will do, it will going to, let me clear all these things, it will going to search the internet. I have given a search tool to it, the agent. I will show that one. So here is the one search web tool I have given. Okay, so it will going to perform search on Google, and it will going to find out all those content. It will going to optimize the content, and it will send to the LLM. So let me send. So first it's searching the company policy tool. Basically this is the RAG retrieval tool, where it will going to search in the company database or the vector database, but it didn't found any information inside the company database. Now it tried to search in the web. So this is the search web tool. And what is the query it sent in the search? Indigo baggage policy 2026, which is correct, and it got this much response. Okay, now from that response it is telling us the standard allowances included 15 kg of checked baggage and 1 cabin bag up to 7 kg. Okay, now I will ask what about the okay another. Okay, let me search about another airline, Air India. Okay, what about the Air India policy on baggage? Silly. So you can see first is trying to find in the company database. If it's not finding anything, then it's going to the search web tool. Okay. So Air India baggage policy for 2026. Got it. So this is the agent system to book flight. Okay. Then let me show you the RAG process. Before that, okay, so I did log into my S3 bucket and I have my database here. So I'll be going to show the RAG process from the high level. Okay, so what will happen when we will upload a document here? It will going to upload that particular document in S3 bucket in this location. Like you can see, there is 2 documents here: Google Code of Conduct and Walmart Code of Conduct. Okay, same we can see here as well, files in S3 bucket. So once the upload is done, automatically it will going to trigger a hook which will execute the ingestion pipeline. Okay, and it will going to put all those chunks of this document in the vector form inside one of my database in the Supabase. Supabase is nothing but a Postgres database which have the vector storing capability. Okay, so let me go to the database and I will show you some of the details. Like I have the document chunks, members, committee. Okay, in this document chunks I have document name, chunk content, metadata, embedding, and the when it's got created. Okay, let me do some query and show you how it look like. just select star. So here there is only two results present, two chunks of details. Okay, so let me do one thing. I'll show you the ingestion flow. I'll going to delete all those details from here first. Okay, I have deleted everything, and also I'll be going to delete these two files from S3 bucket as well. I have deleted those files. So let's just see one more time if everything got deleted from the vector database. Okay, please comment if you guys want to know the proper ingestion and retrieval pipeline, so that I can create a dedicated video on that one. Okay, so now you can see there is zero data available, no chunks available in this vector database. Okay, and nothing is there in S3. Come here and let's refresh the page, and we'll see there is no file. I'll be going to upload some files. Okay, to go home to my projects, rag chatbot projects, oh sorry, rag docs. So I have some document here. I'll take this Google code of conduct. Okay, meanwhile let's have a look on the terminal as well what it is doing. Okay, this one, let me select Google code of conduct. Okay, let's click on uploading. So upload is successful, so we can see automatically the ingestion started here. Okay, so you guys can see here, this is the ingestion already started. Okay, and it did completed the ingestion part now. Okay, now let's go to the S3 and see if there is any file here we have uploaded. Yes, there is one file. Okay, this is just the one page. Let's uploaded a big file to see the process little bit for longer. I'll upload the Apple supplier code of conduct, upload to S3. So upload is happening. Then the ingestion, you can see extracting pages from PDF. You can see this one, right? And these are, it's calling to OpenAI embedding model to create the embeddings of those chunks here. Okay, then let me go S3 and see if that file came here or not. As we can see, the Apple supplier code of conduct file is present and the ingestion is going on. Okay, let's see if it is happening. Yes, the process is going on. So basically it will going to do the ingestion automatically. So while it's happening, let's see the count of the file here, count of the chunks. So till now only 2 chunks is present. Once the ingestion is done, we'll see how many chunks are present there. Okay, meanwhile let me comment this delete command, because by mistake if we're going to run, it will going to delete all the chunks. So for that you can run it and we can see the chunks here. So you can see Google code of conduct one page. This is the 2 file, and as part of 2 file we have 2 chunks here. Okay, this is the one chunk of data. And what is the tag here? Let's see the tags. These are the tags. Then source, from which file it came, category, page level, part of which page number, document ID, and the ingestion date. Okay. Okay, let's wait for this process to complete. Okay, so rag ingestion is done. Okay, so we can see it's uploaded around 10 batch of content. Okay, let's go to the front end database. Let's see how many chunks of data is there now. So we can see before it was 2, now around 954, right? So all those chunks came from Apple document. Okay, let's see those document. I'll go to the front end. Okay, and you can see this is showing now indexed, means already indexed. Let's go to search and retrieve, and I will ask some question here related to Apple. So before that, I will be going to open the document Apple supplier code of conduct. Let's ask some question. Okay, we'll do one thing. We'll take help of ChatGPT to create some question for us. Okay, Apple supplier. Generate some questions to test the RAG retrieval pipeline. What is the maximum work week allowed by Apple supplier? Okay, let's use this question. This will be our search query. Okay, let's search the document. We got 5 results. Okay, so let's see one result here. We have retrieved 5 chunks. Okay, so we got the answer: 64 working hours management applies supply responsibility. As you can see, this is one of the chunks which is related to this particular query. What is the maximum work week allowance by Apple suppliers? Okay, then this is coming from page 62, right? So let's go to the page 62. Where is my folder? Let's go to the page 62. Okay, this. Okay, nice. Here you can see the work week shall be restricted to 60 hours. Correct? The same information we are getting here, and it's telling the page 62. From page 62 it's found this information. So this is possible because we have organized our chunks, we have added the metadata. Correct? So 62 working hours management applies. Okay, this is the data we got. Now if I'll go to the chatbot and I will ask the same question here. Okay, I know this is not related to the airline domain, but this is just the data which is present inside this database, right? So let's query and see what AI is returning us. So which tool is calling now? Search web tool. Okay, basically instead of going to the database, it searched that in the internet. How I got to know is by seeing this tool call. Correct? If this debugging window will be not there, I might have thinking like this went to the database and retrieved those, but not. This went to search from the web. Okay, so I will tell search it in company policy. I'm just forcing the agent to search this one in our company policy, so it should try to call the search company policy tool. Correct? So now agent try to call this one search company policy tool. Correct? This only we want. Like instead of going to the internet, it should call this tool and this tool will do the retrieval. The same thing we have did here, search and retrieve. it will going to search the query and it will get those results. Okay, come here, and these are the chunks of data, correct? These are the data it's getting from the database by doing the similarity search. Okay, now after getting those data, these things will be going to send to the LLM and LLM will give us the response. So by reading those data, LLM is giving response like according to Apple supply responsibility standards, the maximum work week allowed for supplier is 60 hours. And same thing we can verify by reading the document also here, supplier code of conduct requirement. So this is how the RAG works. This is one of the example. Okay, now I have explained my projects. Okay, each component. I'll be going to share this project in GitHub repo and I will share this in link later. Okay, I'm planning to keep all those components, basically PSA system, front end and the AI agent backend in a Docker image. So you can you guys can directly download the image and you guys can run it directly without installing dependencies or without doing any further configuration. Okay, so the only thing you guys might be needing is here, like you have to create on your S3 bucket. You need some configuration key, which one I'll be providing in the document, the GitHub section, and your API key, right? All these things I'll be providing the documentation. Okay, so uh, in next video I'll be uh, try to come up with a system design approach to test this particular chatbot. Okay, because our chatbot is ready, like it's not the complete production ready chatbot, but it is more than the basic actually. Okay, so now we'll be plan to test the capability of chatbot, the tool callings, the RAG process, how much the response is accurate, if it is retrieving the correct information or not, if it is calling the right tools or not, everything. So we'll be going to see how we can design a automation framework or a system which have the capability to test a AI agent system. Okay, meanwhile you guys can go through the LangSmith documentation, LangChain, try to understand how we can build an agent from high level point of view, what are the components, what are the life cycle present, right? And what is the system prompt, what is the vector database, what is called embeddings, those concepts. So it will help us during the testing. Okay, thank you everyone, bye.